The one-dimensional motion problem. There's a classic in physics of trying to emphasize what the meaning of positive and negative are when dealing with vectors. For example, if I have a positive velocity or negative velocity, that has nothing to do with if I'm speeding up or slowing down, because velocity doesn't care about the change in speed. It cares about what the speed actually is and in what direction. Positive direction means which way am I going? Negative, which way am I going? Positive acceleration, negative acceleration does not mean speeding up and slowing down respectively. Positive acceleration means I'm accelerating in the positive direction. Negative acceleration means I'm accelerating in the negative direction. I do not know, if I tell you my acceleration is -5 meters per second squared, I have no clue about what that actually means in terms of movement. So, the one-dimensional determining direction. Position. Is the object on the plus side of 0 or the minus side of 0? That's all that it means. And so if I look at my example right here, I have a starting point right there. 0 is right here. So when I start, I have negative position because I'm on the negative side of 0. Now my fingertip is on the positive side of 0. It's now on the negative side. So my position is negative, 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 positive, 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 0, negative, 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 negative. Recognize that if I go from negative to positive, I have to pass through 0. That's important later on for other analyses. But if I go from negative to positive, positive, negative, I have to go through 0 unless there's a rip in the space-time continuum or we're dealing with a problem that actually can't physically happen. And we do deal with those sometimes. So, that's position. Displacement. Am I on the positive side of the starting point or the negative side of the starting point? Now, it's generally helpful to have the starting point be the same as 0, but that doesn't always work that way. So, in this case, if I'm here, my position is negative, my displacement is 0. Now I start moving my finger. Right now, my displacement is positive, because I'm on the positive side of my starting point, but my position is 0. I keep moving, positive and displacement are both positive. They're opposite sides. My displacement is 0, my displacement is negative, and my position is negative because I'm still on the negative side of 0. So displacement. Is the object on the positive side of the starting point or the negative side of the starting point? Next, velocity. Is the object moving in the positive or negative direction? Let's go back to the great, incredible graphics that I have here. So, starting point is 0, positive velocity, positive displacement, negative, try that one again. Positive velocity, positive displacement, negative position. Positive, all three are positive at this point. Now I come back, displacement positive, position positive, velocity negative. Position has now flipped to negative, velocity is still negative. My displacement is now negative, and my velocity is negative, 0, velocity is positive again. And then the last one we're going to deal with here is acceleration. Now there's 3 ways of trying to figure out direction of acceleration. They all work together, although it's not, when you're first starting it doesn't necessarily seem that way, so pick one that you like. All right, the first one, this is the hardest one to apply when you're first starting out, is what is the direction of the change in velocity? Next one, what's the direction of the net force? And then the easiest one in my mind, if you can remember it, if you're speeding up, velocity and acceleration have the same sign. That means that if the net force acting on me is pushing me in the way I'm going to go faster. If the net force is pushing against the way I'm going, so imagine you're walking along and someone's pushing against your walking, or pulling you back. Velocity and acceleration are in opposite directions, you're slowing down. All right, so, other end, there we go, starting point. Starting point here, I have positive velocity, and suddenly at that point, when I go from positive to negative, my velocity is changing, and my velocity, well, think about what force would require to do that. If I'm going to the positive direction and suddenly my finger goes back, there must be a force pointing in the negative direction. And the force pointing in the negative direction, it's negative acceleration. My velocity also went from positive to negative, and so my change in velocity, so if I went from 5 miles per hour to negative 5 miles per hour, my change is negative 5 minus 5, or negative 10. Again, in the negative direction. And there it is. First time through, this probably doesn't make a whole lot of sense, but the more you think about it, the more it does make sense, and it becomes particularly important later on as we start to predict motion, because that's where we're heading. First we get the groundwork done, and then once we get into Newton's second law, we can start to predict motion. And that is really actually kind of cool.